In this video, we're going to look at symbolizing some more complex sentences into PL. So remember the four types of categorical sentences that we looked at in the last video. And here the P's here are referred to as the subject and the Q's are referred to as the predicate. These are the traditional medieval terms that the logicians who first studied these came up with. These don't have to be single predicates in the sense in which these are, the term predicate is used in PL. These can both be quite complex, and a lot of complex sentences in English can be understood as complex categorical sentences. So take, for example, all dinosaurs are lizard-hipped or bird-hipped. Right. So your first stab at symbolizing this might be something like this. Right. But this is not the right way to do it. Okay. So what this says is for all x, if x is a dinosaur, then x is lizard hipped, or for all x, if x is a dinosaur, then x is bird hipped. Right. All dinosaurs are lizard hipped, or all dinosaurs are bird hipped. That's not right, though. Right. Because that says that they're all one way or they're all the other way. What we want to say is that there are the two categories, and each dinosaur has to fit in one category or another. So it's going to look like this. What you have here is a complex predicate term, right? For all x, if x is a dinosaur, then either x is lizard-hipped or x is bird-hipped. You can also have complex subject terms. So take, for example, all lizard-hipped dinosaurs have feathers. Right here, what you have is this. Everything that is both a dinosaur and lizard-hipped has feathers. So for all x, if x is both a dinosaur and lizard-hipped, then x has feathers. Sometimes categorical sentences will be disguised. So you take this, for example, Milo likes every meat-eating dinosaur. This probably doesn't look like it's a categorical sentence. It actually is, though, right? The way to paraphrase this would be each x is such that if x is a dinosaur and x is meat-eating, then Milo likes it. So this is basically an A sentence with complex subject and a complex predicate, actually. It's going to look like this, right? For all x, if x is dinosaur and x is meat eating, then Milo likes x. Okay. Next, what we'll look at are a few types of sentences with multiple quantifiers. So let's start with this, right? This claim here, somebody loves someone, right? The claim that the world is not entirely devoid of love. To see how to symbolize this, we'll actually start with something that is a little bit simpler. We'll start with Deborah loves someone. Um, Now here, this is going to be pretty simple, right? The someone here is going to be referring to, I mean, this is clearly an existential quantifier you're going to want here. So you're going to want to paraphrase this as there is an x such that Deborah loves x. And then it's going to be symbolized like so. There is an x, LDX. Now, to go back to this, what you're going to want to do for this one is take this D here, the name for Deborah, and then replace this with another existential quantifier. So instead of Deborah here, we're going to have there is a y such that, there is an x such that y loves x. And it's going to look like this. That's going to be the symbolization for this. Remember that the exact variables that you use don't matter. So for example, there is an x, there is a y, lxy would actually mean exactly the same thing as this. The thing that matters is that this one corresponds to this and this one corresponds to this, but which variables are in those places doesn't make a difference. Another thing that matters is, though, that we used a y here when we introduced this variable. And what matters here is not that it's a y, it's that it was a different variable than what we had here. And that is because when you have two quantifiers that have what's called overlapping scope, meaning that they cover the same parts of a formula, they have to have different variables. I mean, look at a thing, I guess, or a string of symbols like this, right? For all x, there is an x, LXX. I mean, this just can't be interpreted, right? Like, who loves who here? Does this mean that, you know, someone loves everyone, or everyone loves someone, someone loves themselves? Like, this doesn't make any sense at all. In fact, this is not a sentence of PL because it doesn't make sense. I mean, you can't interpret this. So in order to make this into a sentence, these quantifiers would have to have different variables, and one of these would have to be, you'd have to have replace each of these with one of the variables in here so that you can see exactly which place in this two-place predicate corresponds to which quantifier. Note though that to say that quantifiers with overlapping scope have to have different variables, that doesn't mean that every sentence with multiple quantifiers has to have different variables, right? If the quantifiers don't overlap, then they can actually have the same variable. So take this, right? If everything is a dinosaur, then everything has feathers. You can actually use the same variable for these two because they don't overlap, right? This quantifier here, it only covers this dz. This quantifier here, it only covers this fz. Because there's no overlap between the two, there's no confusion, there's no ambiguity about what it is that they mean. And so it's perfectly fine to use the same variable for them. Now, of course, I mean, if you are ever uncertain as to whether a pair of quantifiers have overlapping scope, then just use different variables for them, just to be sure, right? Okay, here's another example of this is a very common type of sentence that has multiple quantifiers. Dinosaurs love sandwiches. One way that you can symbolize this is as one A sentence embedded inside another one, but the simplest way to do it is to sort of treat it as two superimposed A sentences that are kind of joined up as a tail. The basic idea is this. We say that if X is a dinosaur and Y is a sandwich, then X is going to love Y. So it'll look like this. Here's the paraphrase. Each X is such that each Y is such that, so we've got two quantifiers here in the front. If X is a dinosaur and Y is a sandwich, then X loves Y. And so this is what it looks like. Two quantifiers in front of this conditional. The condition specifies that X is a dinosaur, Y is a sandwich. And remember, you've got to have separate variables here because you're talking about two different things. And then X loves Y. And that's dinosaurs love sandwiches. And this sort of thing with you're setting up two categories and then expressing something about the relationship between the two, this is a very common sort of sentence.